Hello everyone. In this video we are going to understand what is homogeneous differential equation and how to solve the questions based on homogeneous differential equations. Sometimes a first order ODE written in the form of mxy into dx plus n of x comma y into dy is equals to 0 is called homogeneous differential equation if m and n are homogeneous functions of same degree. So let us understand what is homogeneous function first. A function z is equals to f of x comma y is said to be homogeneous function of degree n if f of lambda times x comma lambda times y is equals to lambda to the power n into f of x comma y, where lambda is my parameter. Let us try to understand this definition with the help of an example. The function f of x comma y be x square plus xy plus y square, and we need to check if this is a homogeneous function or not. For that, what will we do? We will multiply x by lambda and y by lambda. This will become lambda x whole square plus lambda into x into lambda into y plus lambda y whole square. After simplifying, we can take lambda square common from x square plus xy plus y square, and we can notice that this bracketed term is nothing but f of x comma y again. Therefore, f of x comma y is homogeneous function of degree 2. Now understand that the degree of the homogeneous function depends over the power of lambda we are taking common. We can see the definition again, that homogeneous degree is of n, where n is the power of lambda. Let us try one more question. F of x comma y is equals to y into sine of y by x. Similarly, taking f of lambda x comma lambda y, now replacing y by lambda y and x by lambda x in this function. So this becomes lambda times y into sine of lambda times y divided by lambda times x. Here lambda into y into sine of y by x again, and we can see that this bracketed term is again f of x comma y, and here the power of lambda is 1, therefore f of x comma y is homogeneous function of degree 1. Another question, f of x comma y is equals to x square plus y, replacing x by lambda x and y by lambda y. This becomes lambda x whole square plus lambda times y. And we can see that we cannot write it in the form of lambda square into f of x comma y. Therefore, this given function f of x comma y is not homogeneous. From here, we can make a note which says polynomial function is homogeneous if each term in polynomial has same degree. As we can see in the example number 1, it is a polynomial where each term of the polynomial is having the same degree. So this becomes a homogeneous function directly. But in third question, we have polynomial as x square plus y, and degree of each term is not same because the degree of x is 2 and degree of y is 1, and they both are not equal. So directly we can say that this function is not homogeneous function. The next thing we are going to understand is how to solve a homogeneous differential equation. For that, we are going to follow some simple 3 steps. Step number 1 says, write down given differential equation in the form dy by dx is equals to minus of m upon n. And step number 2 says, put y is equals to v of x, implies dy by dx is equals to v plus x into dv by dx. And in step number 3, we will put these substitutions in step number 1, then it will be reduced to variable separable form. Let us try to make the understanding of these steps with the help of some examples. The question number 1 says to solve the differential equation given as this. The first thing we have to do is to check if the given differential equation is homogeneous in nature or not. For that, we can firstly convert the equation in the form of dy by dx is equals to whatever the function is. And now we have to check if the right hand side of this question is homogeneous or not. That is, we have to check if the numerator of this term is homogeneous or not and denominator is homogeneous or not. And we can clearly see that numerator is a polynomial where degree of each term is 2 and denominator is again a polynomial where degree of every term is 2. Therefore, numerator and denominator, they both are again homogeneous in nature. Then we can proceed with the steps we have discussed to solve this differential equation. The step number 2 says that we have to put y is equals to v times x, which implies that the value of dy by dx is equals to v plus x times dv by dx. Now, taking the value of dy by dx from equation number 2, this becomes v plus x into dv by dx is equals to 3 times the value of y have been updated as v times x So the right hand side of the equation becomes this form. And we can take x square common from both numerator and denominator, and this equation becomes this. Now simplifying again, keeping the x into dv by dx term on left hand side and taking v on right hand side, after taking LCM, and the simplification of the right hand side term be v square plus 2v divided by 2 times 1 plus v, and the left hand side is x into dv by dx. And we can see that this equation have been reduced to variable separable form, which is quite easy to solve. 2 times 1 plus v divided by v square plus 2v into dv is equals to dx by x. Now integrating both sides, this becomes log of v square plus 2v is equals to log of x plus log of c, implies log of v square plus 2v is equals to log of x into c. Taking anti-log both sides, it becomes v square plus 2v is equals to x into c. Now back substituting the value of v, which will be y by x, this equation becomes y square by x square plus 2y by x is equals to x into C, and in the question we are also given the y value at x equals to 1. Now using y of 1 is equals to 1, this equation becomes 1 by 1 plus 2 by 1 is equals to 1 into C, which helps us to calculate the value of C as 3. Therefore, the final answer be y square plus 2 times xy is equals to 3 into x cube. The second part be, noticing this question, we can clearly see that we cannot solve this problem with the help of reducible to variable separable method. Also, when we convert this problem in the form of dy by dx is equals to y square plus 2 times xy divided by x square. Let this be as a function of f of x comma y. Clearly we can see the numerator of this function is a polynomial where each term has same degree, and so is the denominator. Now we can solve this equation with the help of homogeneous differential equation method, and this method says that we put y is equals to v into x, implies dy by dx is equals to v plus x into dv by dx. Now using this values in equation number 1, the equation number 1 becomes v plus x into dv by dx is equals to v square x square plus 2 times v into x square whole divided by x square. Taking x square common from the numerator, this equation simplifies to 2 times v plus v square. Now keeping x into dv by dx term on one side and taking v on the right hand side, this equation becomes v square plus v. Clearly this equation have been reduced to variable separable form, and we can write it as dv by v into 1 plus v is equals to dx by x, integrating both hand sides. Now on the left hand side we have to apply partial fractions first and then we have to integrate. Taking the partial fractions, we can directly write it as integration 1 by v minus 1 upon 1 plus v into dv is equals to integration dx by x. This becomes log of v minus log of 1 plus v is equals to log of x plus log of c. Using the log properties, we can write it as v upon 1 plus v is equals to log of x into c. This becomes v upon 1 plus v is equals to x into c. Now back substituting the value of v as y by x, this becomes y by x upon 1 plus y by x is equals to x into c. After simplifying, this equation be y upon 1 plus y is equals to x into c. Taking the denominator term on right hand side, this becomes x into c into 1 plus y which be y is equals to x into c plus x into y into c. Taking this term on left hand side and taking y common, please make a correction that we have x here, not 1, because when we will take LCM here, the denominator term will be x plus y, not 1 plus y. Therefore, this will be x square, and in the last there will be x square into c, which will be the final solution of the given problem. Let us try one more question. Clearly, this problem is not solvable in variable separable form, and also it cannot be reduced to variable separable form. But when we will write it in the form of dy by dx, which will be x into y divided by x square plus y square, which will be written as function of x comma y, to put y as v times x, which means dy by dx is equals to v plus x into dv by dx. And using these equation number 2 in equation number 1, it becomes v plus x into dv by dx is equals to x into v times x divided by x square plus v into x whole square. Taking x square common from the numerator and denominator, this equation will simplify to v upon 1 plus v square. Again, keeping x into dv by dx term on one side and taking v on right hand side, this will be v upon 1 plus v square minus v, which is equals to v minus v cube whole divided by 1 plus v square. This will got cancelled out, and the remaining term will be minus v cube upon 1 plus v square. And the final equation be x into dv by dx is equals to minus v cube upon 1 plus v square. And we can clearly see that this equation have been reduced to variable separable form. Therefore, we can write it as now 1 plus v square divided by minus of v cube, or you can keep this minus sign on the right hand side only. Simplifying the left hand side first, 1 upon v cube plus 1 upon v into dv is equals to minus of dx upon x. Now integrating both sides, this will become minus of v to the power minus 2 divided by 2 plus log of v is equals to minus of log of x plus c. Now back substituting the value of v here as y by x, this will become minus of x square by 2 times y square plus log of y by x is equals to minus of log of x plus c. And we are given the value of y as 2 at x is equals to 1. Therefore, using y of 1 is equals to 2, equation number 3 will become as minus of 1 upon 2 into 2 square plus log of 2 is equals to minus of log 1 plus c, and we know that log 1 value is 0, and this will simplify and give the value of c as minus 1 by 8 plus log 2. Therefore, equation number 2 will become as x square upon 2y square plus log of y by x is equals to minus of log x minus 1 by 8 plus log 2. The next question be, again this question is not in the form of reducible to variable separable form, and nor it can be converted into reducible to variable separable form, but when we will write it in the form of dy by dx as x cube plus y cube divided by x into y square, which will be treated as f of x comma y, and this f of x comma y is clearly a homogeneous function. Therefore, we can start putting y as v times x. From here we get dy by dx as v plus x into dv by dx. Substituting these values in equation number 1, it will become v plus x into dv by dx is equals to x cube plus v cube into x cube divided by x into x square v square. Taking x square common from both numerator and denominator, this will simplify as 1 plus v cube divided by v square. We can also write it as 1 by v square plus v, and the final simplified version be v plus x into dv by dx is equals to 1 by v square plus v, and we can cancel v from both sides, and the simplified version be x into dv by dx is equals to 1 by v square. Now clearly this equation is in reducible to variable separable form, and we will separate the variables as v square into dv is equals to dx by x. Integrating both sides, this will become as v cube by 3 is equals to log of x plus log of c, implies v cube is equals to 3 times log of x into c. We have simply used the properties of log here. Now back substituting the value of v as y by x, this will become y cube by x cube is equals to 3 times log of x into c, which will be our final solution to the given problem. I hope you have made an understanding that what is homogeneous function first and how to solve a differential equation which is in the form of homogeneous differential equation. If you found this lecture useful, then don't forget to share it with your friends. Happy learning!